The SAT isn't typically this straightforward when it comes to the equation of a circle, so we want to take advantage of understanding it this very well. They're asking for the radius of the circle, and the reason that this is tough is because we feel like it looks like the equation of a circle, but it's a little bit off. And let's put our like terms together, and maybe that'll help us understand why. So x squared plus 4x plus y squared minus 2y, and that equals -1. Okay. So what's wrong with this? Well, remember the equation of a circle, it's going to be x minus h squared plus y minus k squared equals r squared, where h and k represent the coordinates of the x and y, the center of the circle, and the coordinates of that center of the circle, where this is your x coordinate and that is your y coordinate. Now, we need it to be squared, but we don't want one term to be squared. We want it to kind of look something like this, right? But that's not what we have yet, and we can't just kind of throw that on there. And what we have to do is we got to complete the square. The first thing we're going to do is we're going to break these up into two separate addition problems. So now it's x squared plus 4x plus y squared minus 2y. And what we're going to do is we're going to complete the square here. And completing the square in a nutshell is essentially adding numbers to make it a more symmetrical shape, if you will. That way we can reorganize the information in a way that's convenient for the equation of a circle. Hopefully that helped clarify it. Okay, so now, but all you need to know is that to complete the square is that we look at our a term here, which is 1, and we look at our b term here, which is 4. And what you do is we have to create a third term, essentially. We have to create a third term. We essentially want to create x squared plus 4x plus something else, a third term. And that third term is created by b over 2a. And we're going to square this result. Now, b is 4. So we can rewrite this as 4. 2a, which is just 1. Okay. And then that just becomes 2 on the bottom. And then when we end up with 4 over 2 squared, that just becomes 2 squared, then 2 squared is 4, and then we have 4. Why all that work to do this? Well, here's the thing. When we have a trinomial here, where now it's a perfect square, like all the way through, we can just rewrite this now as x plus 2 squared. If I were to actually FOIL this, it would give me back this here. And now we can see we're getting a little bit closer to that equation of the circle. All right, we add that now, and we're going to do the same thing to the y here. So we want a y squared minus 2y plus some kind of third term where it's b over 2a, and that result is squared, where b is -2, and then 2a, well, a is actually still 1. So what we end up with here is -2 divided by 2. That gives us just -1, and -1 squared is just +1. And what we get here is this turns into y minus 1 squared. And now what we realize is that we've now added 4 here, 1 here, so that's a total of 5, and we cannot forget to add it to this side, because that's actually what they're asking for, is the radius. So now what we see is -1 plus 5, which gives us 4. Now 4 is what equals r squared, and we want to just know what r is. So r would end up being 2 because we just square root both sides, and that gives us a. I recommend practicing this problem a few times.